So for our research project, we looked at the effects of temperature and moisture on tick abundance. So in Massachusetts, the normal temperature patterns have seen increasing variation due to global climate change. This has resulted in longer active periods for ticks. Longer tick active periods have the potential to increase the spread of tick-borne diseases such as Lyme disease. And these drastic temperature shifts could greatly affect the reproductive rate of ticks as well. So knowing how temperature and moisture affect the abundance of ticks that contain pathogens would allow for possibly mapping vector tick populations and predicting possible outbreaks of tick-borne diseases in the state. And we hypothesized that if we compared pathogen-positive tick abundances to both atmospheric temperature and precipitation levels of the same time period, that we would see a significant correlation between the temperature, precipitation, and pathogen status of the ticks.
Next, we'd like to discuss the methods section for our research. As for the methods for which our group used in order to study possible correlations between tick pathogen abundance in relation to atmospheric temperature and precipitation, we used datasets collected by multiple teams who have worked in the Harvard forest that have been uploaded onto the Neon Data website. For this datasets, the ticks were harvested from the area in 30-minute intervals, 2 days of each month for roughly 5 years in total. This data that had the results for tick pathogen abundance was then observed and compared with the Neon data for the precipitation and temperature during the same time frame. And if you look here at the bottom, these are areas in which the ticks were collected from the Harvard forest. In the bottom right image, you can see the method in which they're using to collect ticks, which is dragging a drag cloth along the ground of the forest. And then in the bottom right image, you can see the way that they collected the ticks from the drag cloth, which is usually just using forceps to remove the ticks.
For our results, Figure 3 will show the average monthly temperature, and Figure 4 will show the average monthly precipitation as we compare both variables to tick abundance with positive pathogen status. We can see that the highest amount of pathogen-positive ticks had been recorded in June 2017 with an average of about 1.66. For precipitation in Figure 4, we do see sometimes when the prevalence of ticks positive for pathogen does positively correlate with precipitation amounts. For example, from June 2017 to August 2017, they are both decreasing. When we compare it to the average monthly temperature data in Figure 3, there is a slightly more negative correlation. For example, during the months of June 2018 to July 2018, the average temperature increased, but the number of ticks positive for pathogens actually decreased. Using RStudio, we found our p-values for average precipitation at 0.4522 and for average temperature at 0.0817, both of which are greater than 0.05, so that tells us that although there were times of correlation, there is not enough evidence to support a significant difference between temperature or precipitation on tick abundance in the Harvard forest during these two seasons.
As we saw in the results section, the statistical tests from RStudio did not show significant correlations between temperature or precipitation on pathogen-positive tick abundance. These findings would suggest that the two variables do not affect the abundance of ticks. This contradicts previous research studies on the topic that suggest that they do. However, for this research project, we used data on temperature, precipitation, and tick pathogen status from a very narrow time frame, which was only 2 seasons. We also collected data from a single Neon site. Harvard Forest in central Massachusetts. Future studies could use data from other neon sites in Massachusetts or other parts of New England, or even other parts of the country or other countries with different climates. Future studies could also look into the effects of temperature and moisture on the abundance of other vectors of human diseases like mosquitoes or flies.